basically, like when you get into hips and stuff, that stuff comes into play. I think there's a more in-depth thing than just cutting a basic common rafter, and that's what I like about the calculator is that sometimes you don't need to. Sometimes you just need a quick and dirty like step-up block for a truss or something like right here. But basically, like if you wanted to use the trig identities, you just have to lay out your diagram correctly, because the connection that you have to make is that you have to connect these points, basically. Center of the ridge, which would be the center of these 2 points of the outside wall. So you're basically just drawing a straight line all the way up, perpendicular to the plate line, basically. And then this little stand right here is just determined by your R value that you need. So sometimes you'll put like a 2x6 ceiling or even bigger dimensional lumber, and then you'll plate around it like a knee wall almost, and then you could put your rafter on top of that little knee wall. Depends on like the codes for your area, I guess. Like for us, like you have to raise it up so that they can insulate in there because Canada's cold. So anyways, for anyone that actually did care about the trigonometry, anyways, I did start doing the like the trig identities and stuff, but that's a little bit more advanced. I don't think you have to make it that hard sometimes, but it is good to know. The trig identities, like the SOHCAHTOA that we learned in, I don't know what, grade 3 or whatever. It's, again, there's a lot easier, simpler ways to do that, but also when you're dealing with hips and irregular roofs, sometimes it's just like another tool to have that makes determining ratios and similar triangles methods easier, because that's essentially what you're doing, right? You're so let's just draw this out really quick. Like this is like when I show up, if I was to cut a roof, let's say it's just a shed, and I'm not going to use the same numbers, so maybe we can work through it together. If there was a shed, let's say this time, whatever, there's a door here. This is your shed. And the midpoint would be somewhere, I don't know, center of the door. This line will carry all the way up. Okay, so we determine an overhang, and let's just say, for sake of example, this whole outside to outside of wall is, I don't know, 10 feet for easy numbers. 10 feet, okay? And then we're going to use the same ridge. Maybe this time we can use a 2-ply ridge, and then basically just mirror imaging it to the other side just to get it kind of close. That's just find 2 points that mimic both sides, so it helps to have a good diagram to visualize it, because some people don't have that in, well, not, maybe they just never seen it this way, I guess. There's many other ways you can do it, but I think it's fun sometimes to just practice at home. Basically, it's more in-depth, and it's just another tool in your pouch, basically. That's how I thought of it. Understand why this is important, and the stepping of the square, that works as well. I've seen a whole dude step a square for a whole house, and he did it just as fast, like some of those old timers. Let's just assume that this house is 10 feet across, or shed, whatever you want to call it. There's a 12-inch overhang and a 9/12 roof. So I set it up like this, just for a different flavor, I guess, different numbers, and we can work it through together. I put a double ridge here, just to throw in a little bit, so we know two by material, so 3 inches across from here to here. Basically, all the difference is now I'm subtracting half of 3 inches, which would be 1 ply of the ridge, which would be 1.5 inches. So the way I set this up is, I know the angle. So the angle is like this. This simplifies, this equation simplifies into this. So the angle, in this case theta, is 9/12. That's the the similar aspect of it. If I went 12 inches this way, it's going to still be the same angle. I'm going to go 9 inches up this way. So by the time I get to 12, I'm going to be at 9 inches. And if I double that, if I get to 2 feet, or let's say whatever, I'll be at 18 inches. You know, that's the relationship, the similar triangle relationship with the roof and the pitch. So basically, that relationship still exists here. So if this 9 over 12 is equal to the rise over run, this, from this point to the center of the ridge, is going to equal this. So I can set it up as the rise as my unknown right here, this point right here. And so I know that that's the variable I'm looking for. So let's just call it, for sake of a better term, x, just to be more clear. And then the run would be 10 feet divided by 2, which is 5 feet, minus 1.5 inches. It would be 4 foot 10 and a half. This is in inches, keep in mind. So I got to convert 4 foot 10 inch and 1/2 into inches. So I go 4 foot 10 and a half. So 10 and a half, you basically got to convert to a decimal. And you do that by dividing it by 12. Or 10 and a half inches over the 12 inches. That's the conversion. I'll show you why that is, but just to be quick and here, I was just going to do it that way.